Every day, we're creating the future. And we have enormous challenges to overcome. But challenges are what drive us. We've been solving difficult problems for more than a century. We helped save the U.S. cotton industry from being decimated by pink bollworms. We've developed nutrition-based solutions to prevent breast cancer. And we've created environmentally sustainable methods to clean up Superfund sites. But the world is a complicated place. That's why we never stop looking for solutions. In our vision of the future, there is enough food to feed everyone. Cancer and type 2 diabetes are eliminated through precision nutrition plans. And foodborne illnesses are no longer a threat to the health of your family members. We envision a time when rivers and oceans are cleaner. Mining and industrial contaminants no longer impact nearby communities. And currently endangered species have healthy populations once again. We foresee a future where differences are valued and make communities stronger. Every day, we're putting science to work to create our vision of the future. We're looking for new ways to solve problems related to health, food production, the environment, commerce, and society. We're educating the next generation of leaders and change agents and teaching them skills to prepare for the challenges of tomorrow. We invite you to join us and help to build the future you want to see.
Thank you, everyone, for joining us at our first ever Coffee with Cals event. But before we get started, I wanted to turn it over to Shane Burgess, the Dean of the College and Vice President of Agriculture, Life and Veterinary Sciences and Cooperative Extension, to say a few words about the series and why we're here today. If at any point during the session you have questions about what we're presenting, we'd love to hear from you. Just drop your questions in the Q&A section at the bottom of your screen. We'll have time at the end to field questions. Thank you. Shane?
Well, good morning, everyone, and thank you for joining us today. This is our first Coffee with Cals, and here you'll get a deeper perspective into the work of our talented and innovative researchers. Most important, you'll get to see how it impacts you. Thank you to our development team for creating this opportunity for you to learn more about the college, and also thank you to the faculty who are going to be involved. You know that the University of Arizona is an incredibly powerful research engine. Last year, we had $730 million in annual research expenditures. In 2018, which was the last year of rankings, the National Science Foundation ranked the U of A top 20 public university for research expenditures. That's a really big deal because there are 4,500 research universities in this country. But the UA, even more importantly to me actually, the UA is ranked #1 in research universities in the nation as an American Indian Alaska Native serving institution and a Hispanic serving institution. So given what our mission is, we are the #1 research institution in the country, and that's a huge deal. U of A's research generated a direct economic impact of $4.1 billion in FY18. Again, that's the last year of the data that I can get. And we touched all 15 counties, unlike the other two universities. We're the only university in the state that does that. Cal's research is a key component of the university's research. Last year, our research faculty created 954 jobs within the college itself because of the research they did and the research grants they got. And it contributed directly to paying another 1,236 additional U of A employees. Plus, we don't have a number for this, but we created a number of jobs and projected jobs in the counties for thousands of Arizonans, especially through cooperative extension. Another time we can talk about our spin-out companies, our licenses, and public-private partnerships that have generated income for people all around the state as well. So we need to protect CALS as a research engine, especially as we enter what promises to be a very severe economic shock in the next few weeks and months to come. So CAL's faculty are currently working on an amazing variety of areas with local, state, national, global scientific and economic impact. This ranges from colon cancer prevention by precision nutrition, empowering agriculture to address the challenge of feeding 10 billion people by 2050, the changing landscapes of our forests and in the face of wildfires, and those of us living near Tucson know about that, the challenges around endangered species all over the world. U of A is going to be announced very soon, you heard it first here, as the #1 university for water research in the world for the 3rd year running. This is the top ranked university in the entire planet, and most of that research that's creating that ranking is coming from CALS. So I hope you have a chance to learn about all these and more during this webinar series. Frankly, the webinar series could go on sort of daily for the next year, and we probably wouldn't cover everything. But today I'm really excited to introduce you to one of our phenomenal researchers, and this is our infectious disease expert, Dr. Gayatri Vedantam. Gayatri is a professor in the School of Animal and Comparative Biomedical Sciences, and she's also an employee at the US Department of Veterans Affairs, where she's a research career scientist. So we are lucky. This is another one of our partnerships, a partnership between our college and the US Department of Veterans Affairs, thanks to Gayatri. So today you'll get to know more about Dr. Vedantam and how she and her colleagues are fighting infectious diseases, including a human disease, C. difficile, which is very, very important right now in the SARS crisis, and how she and her colleagues have pivoted to have a massive contribution around our community for SARS-CoV-2 and the COVID-19 crisis, and also her larger area of focus, which is antimicrobial resistance. Again, an existential threat to us on the planet. It hasn't gone away just because we're fighting with this COVID virus. So again, thank you for joining us, and I'm as excited as you are to see what Gayatri is going to present.
Thank you, Shane. And thank you, Gayatri, for joining us today. We're really proud of the work that you're doing. There are so many initiatives across the college that are aimed at combating infectious disease. I'd like to start with one, though, that is particularly timely. Bend the Curve. Can you tell us more about that? First of all, what is it?
Thank you, Alex. I will be happy to share some information on our Bend the Curve project. Before I do that, I would like to begin my presentation by acknowledging our native lands, by acknowledging our tribal emergency management and healthcare systems, and most importantly, the tribal communities that have allowed us to partner with them in tackling these really important public health concerns. So the Bend the Curve project is our hand sanitizer effort, which we started back in March of this year. And the goal was to make and donate a World Health Organization recommended hand sanitizer to whoever needed it in the state of Arizona. The project is actually called Bend the Curve with Community Support, and I hope to share how much of the community has contributed and supported this project a little bit later in this presentation.
Excellent. So, first of all, why are we doing Bend the Curve? What is what got us into doing this?
So that's a great question. When the University of Arizona decided that we had to ramp down our research efforts in March as parts of the university were closing down, we realized that we had a wonderful opportunity here. We are a research group of microbiologists, and we're interested in the prevention and treatment of infectious disease. And we have this wonderful, talented, enthusiastic group of people in our laboratory who were just itching for something to do, to contribute to the effort as their own research was ramping down. And so with my collaborator, Dr. Vishwanathan, we decided, well, what can a group of interested microbiologists do to help the community? And the answer was, we can make hand sanitizer in the most safe and efficient way and share it with our partners.
Wonderful. I actually happen to have a sample of the product here. And, you can tell just from the bottle and the way it sloshes around inside there that it's not quite the same thing that we purchase at, the drugstore. or commercially. So what are the differences between what you're making and what we might buy just as consumers, and why?
So there's two major differences. The first is, you're right, our formulation is a liquid formulation. And I have my own little bottle here as well. So we have two kinds. We have these little personal use bottles. We also have the spray bottle that you used. So the first difference is, with a liquid formulation, you can apply it onto your hands just like you would do with store-bought product, but you can also spray it onto large surfaces. And for our healthcare and first responder partners, that's really important, where they can sanitize a large surface. The second difference is, our product has no additives, dyes, preservatives, or fragrances. So it's safe to use for anyone that might have a reactivity to those compounds.
That's great. Thank you so much for taking that on. We actually, earlier this week, took a trip to your lab to see how the process is done. And we actually have a video of that. Can we play that video, please?
Absolutely.
All right, welcome back, everybody. Thank you so much to Dr. Gayatri Vedantam for agreeing to take us on a tour of your lab today. But before we go in, we have to suit up, right?
That's right, Alex. So it's really great that you're here, and welcome to the School of Animal and Comparative Biomedical Sciences. So before we go up to that hand sanitizer production lab, I'd like you to put on some PPE.
All right.
And the first thing you're going to put on is a surgical gown, which is what all of us wear to protect ourselves and people around us.
Like
so,
this?
Like that. Your arms go in, and then your other arm. Perfect. And then we tie the back.
All right, like this, right?
The next thing you're going to put on is this N95 mask.
All right.
Now you're wearing a cloth face covering, which is perfectly appropriate, but because we are going to be up in a research area, we request that everybody use the highest level of face protection, which is an N95 mask. So I'm going to step away from you so that we maintain distance, and you can take off that mask and put this one on. It has a little metal bridge here, which is flexible, so make sure to pinch it on your nose for a snug fit.
Excellent, thank you.
Okay,
These are the masks that were so hard to come by just a few
that's right.
short months ago, right?
But we are able to get them for research now.
All right,
Fantastic.
am I all good? Am I good to
You're
go?
set and ready to go.
Excellent,
Okay.
thank you. All right, so here we are with the actual hand sanitizer production team, who's going to walk us through the process of how we actually make the final product. But first, can we hear a little bit about yourselves?
Yes, I'm Jennifer Rojas. I'm a postdoctoral fellow in the Viswanathan and Vedantam laboratory. So my interest is in looking at how intestinal pathogens cause infection, and using the knowledge that we gain from that, we want to devise strategies to prevent or treat infections.
My name is Cole Pitts. I am a student researcher here, majoring in microbiology, and I've been working in the lab for several years now.
My name is Daniel Kita. I'm a recent physiology graduate, and I'm starting my master's in physiological sciences, and I'm interested in metabolic diseases such as diabetes.
All right, thank you all. Shall we go into the lab?
Sure. Okay, so this is the formulation of the hand sanitizer we use in our production, and it's based off of the WHO formula, and it uses hydrogen peroxide, glycerol, ethanol, and water. So in the production, in our production, we make sure that the things that we could sterilize, we do sterilize. So we autoclave the glycerol, we autoclave the water, and we also autoclave the containers, the main carboy that we use to where we mix it, even the measuring beakers and the measuring cylinders. So the first thing that Cole would do is to pump 39 liters of ethanol, and we're using 200 proof USP grade ethanol. he will measure that, and Daniel is helping pour it to our carboy, and fill this jug. This jug could accommodate up to 50 liters of hand sanitizer solution. So once we measure out all the components of the hand sanitizer and fill it into the jug, the next step is to mix the solution really well. We do this by drawing out the solution and putting it back in several times. So it's usually about, we draw about the entire volume, basically. So we draw 50 liters of the solution and put it back into its original container to get a good mix, because we want to ensure that the glycerol and the hydrogen peroxide and the ethanol are mixed together correctly. The next step we'll do is to take out some sample of the solution that we just made, and measure its alcohol content. Okay? We're going to do that with the use of a hydrometer. So we just spin this in the solution and wait for it to settle. So now our hydrometer is giving us a measurement of 79% alcohol content. And then now we're ready to dispense the product into the bottles. So in the past, we've been dispensing in smaller volume. So we used to dispense in the travel bottles, also in small spray bottles, which could accommodate about 270 ml. These are 470 ml containers. But because of the increased demand for the hand sanitizers, it was difficult for us to fill smaller volumes. So now we only dispense in higher volume bottles. We now use the 32-ounce spray bottles, and we also fill these half-gallon jugs that were donated to us by Shamrock Farms through our contact, Josh Moody. Okay, so we'll start in the filling up the jugs. And so this is our finished product. Our labels are provided by Facilities Management, Sign Shop, and it was Bill Florence who designed this label for us. And after that, we just put them in a box. And we also put in an MSDS sheet inside, which contains all the information about the safety of the product. And then we seal it.
Well, thank you, Gayatri, for giving us the time, and thank you to your team for letting us see the process. It was such a great time getting to get into the lab and see it in person.
I'm glad you enjoyed it, Alex. We enjoyed hosting you. I want to reiterate, like Dr. Jennifer Rojas said, our product is really a medical grade product because we are sharing it with our healthcare providers and first responders. We've gone to extraordinary lengths to make sure that it's made under completely aseptic conditions. And we also have to quarantine our product for 72 hours to make sure that it's safe before we hand it out. So there's a lot of effort that goes into the making of the sanitizer.
Excellent. But that's only one small part of what you do, right? Can you tell us more about the research that you're doing and how it contributes to how we fight infectious disease?
I'll be happy to do that. I'm going to share my screen now and talk first a little more about the sanitizer project and then go into our research. So hopefully this will work. Can you see the screen, Alex?
We can.
Okay, perfect. All right. So thank you again for this opportunity to share some of our research with you. As Dr. Burgess mentioned, I'm a professor in the School of Animal and Comparative Biomedical Sciences here in CALS at the U of A. I'm also a research career scientist for the state of Arizona for the Department of Veterans Affairs. And today I would like to share with you a little more about our hand sanitizer project and then talk with you about our research efforts. So who are we? And as I said earlier, we are a group of very enthusiastic microbiology and infectious disease researchers that are using this time to support our community with a product that we think will help in the public health efforts to mitigate the SARS-CoV-2 infections. The project is led by Dr. Vish Vishwanathan and myself. We're both professors in ACBS. And this is, and I hope you can see my arrow, this is our Bend the Curve with Community Support Hand Sanitizer project. So Dr. Rojas gave you a lot of information about how the actual product is made. I would like to share with you that in the last 3 months, we've made over 4,000 liters of the product, and that is enough to fill about 30,000 of these personal use bottles. And as we shared with you, we are now making these small personal use bottles, the spray bottles, and the very large refill containers as well, because demand for this product has really skyrocketed. So who does our hand sanitizer go to? And we have been so honored and fortunate to be able to work with a number of different folks who have been the recipients of this product. I am going to acknowledge all of those who I can remember. They probably won't fit on one sheet, but a lot of the product has gone, as I said before, to healthcare providers and first responders, and they're all listed here in green. They include all of the hospital systems for the most part in the Tucson area. We have also shared with the U of A community, including the police department, and for the entire antibody testing project for the University of Arizona that many of you have heard about, as well as our communities that provide medical care for the homeless and for those living in shelters. Other than that, most of the product has gone to our Native American communities, and to date, all of the communities that we have been able to share product with are listed here on the right in blue. And we continue to provide product for these communities as and when they require. And that's the reason why we are making the product at a rapid pace every single week. You met a couple of the team members, but this is just a shout out to all of the people that have been involved in this project. As Alex can probably testify, it's not very comfortable to wear that mask and all of this PPE and work for hours at a time, but we try to make it under the most aseptic conditions. So our entire dedicated team is composed of research associates, but more importantly of undergraduate students who are back on campus helping us every day with getting this product out to our community. So a big shout out to them. Obviously, this project would not have been possible without tremendous support from our UA, our CALS, and our Arizona communities. And here's a few of the people that have really been instrumental in making sure that our sanitizer project stays alive and productive. Dr. Burgess and Dr. Anton have been cheerleaders for this project, along with Dr. Patricia Stock, the director of our school, right from day one. We've received incredible support and advice and encouragement from our CALS entrepreneur in residence, Emily Toker, as well as from multiple people at the University of Arizona, including people in the VP's offices, facilities management, and CALS faculty and staff. And a very special thank you to Dr. Trent Tigerstrom. He's the Associate Director of Tribal Extension Programs, and you can see him here on the right in this little picture. He personally has driven our product all over the state of Arizona and handed it off personally to all of those communities that I mentioned a couple slides ago. And the greater Arizona community has participated in an amazing way as well. And the biggest shout out there is to Shamrock Foods. These are critical mission partners for CALS and the University of Arizona. And Shamrock has donated thousands of these half-gallon milk jugs, which we now use as refill containers for whoever has gotten our spray bottle formulation of sanitizer. So this is Gloria Santana, the local contact for Shamrock Foods, and they have been so incredibly generous, just sending the huge big milk truck that pulls up outside the ACBS building, drops off pallets of milk jugs, and drives away. They are just amazing contributors to this project. So as I mentioned earlier, hand sanitizer is just a small part of what we do. We are an infectious disease research group, and we study ways to identify and prevent and treat infectious diseases. This is almost the entire team that has now been meeting over Zoom for 3 months. President Robbins joined us at one of our lab meetings to cheer on the sanitizer project. And so I would like to acknowledge the team. They are really the fuel that keeps this ship running, and they are everything as far as we're concerned for our research efforts. So what kind of research do we normally do in our group? And this is for Dr. Vishwanathan and the Vedantam laboratories. And let's hope the slide advances here. So we study antibiotic and healthcare associated infections in both humans and animals. We also study different kinds of adult and pediatric diarrheas. So we are a gastrointestinal research laboratory. We perform infection surveillance and epidemiology for these infections for the state of Arizona. And we use all of the knowledge gained to design and engineer ways to prevent infection. And the focus of our 2 research laboratories is the engineering of biologics and vaccines to prevent infectious diseases in both humans and animals. Why do we have this research focus? And it is because, unfortunately, there are a lot of infections worldwide, but also in the United States, that are associated with being in the healthcare system or having contact with the healthcare system. So the CDC says that there are 2 million healthcare associated infections in the United States every year. So these would be infections that someone gets because of being hospitalized or because of getting antibiotics in the hospital system. A large number of these, 99,000, are fatal. And overall, the treatment and the management of these infections imposes a $30 billion cost on our healthcare system. One of these infections, which is very prevalent in US healthcare systems, is called Clostridium difficile infection. Some of you may have heard about this as C. diff, which is the colloquial term for this infection. And what this is a very ironic infection because it is associated with the use of antibiotics. So when you take antibiotics, they wipe out both the good and bad bacteria in your GI tract, allowing for this C. diff bacterium to colonize the GI tract and cause infection. This is a disease that affects not just humans, but also agriculturally important animals. So neonatal piglets, calves, and foals in our country are tremendously susceptible to C. diff infection. In humans, there are about 1 million cases annually, about 30,000 deaths caused by C. diff infection. The cost of treating every hospital-acquired C. diff infection is about $40,000. And overall, this single infection alone imposes a $6 billion cost to our healthcare system. Unfortunately and importantly, there is currently no vaccine and no way to prevent this disease. The only treatment is more antibiotics, which, as you can imagine, continues to precipitate cycles of the infection. So over the past 10 years at the University of Arizona, our group has basically spent a lot of time to try to prevent C. difficile infections and come up with methods of doing so. We identify C. difficile infections in southern Arizona hospitals and farms. We then use molecular biology and state-of-the-art genetic tools to understand how C. diff causes disease. And we use all the knowledge that we've gained to develop next-generation biologics and vaccines to prevent and treat C. diff infection. Since our work focuses both on humans as well as animals, we call our approach the One Health approach. And since all of our research actually works with patient samples or veterinary samples, we have a bedside to bench, which is the research bench, back to bedside paradigm for our research. So one of the products that we're really excited about is this very safe and cost-effective biologic that we have designed to prevent C. diff infection. This is a once-a-day oral formulation that looks like a little bit of yogurt, or we can package it into pills, and we've developed this to prevent C. diff in both humans and animals. It's an extremely small dose, as you can see, 1/4 of a teaspoon is very, very effective at completely preventing disease in our animal models, which are also our agriculturally relevant models. And this product is now being further developed to go into the human clinical landscape. None of this work will be possible without a lot of support from collaborators, scientific entities, and scientific funding agencies. And so I'm going to quickly acknowledge those on the next slide before I move forward. So we have a number of existing collaborations that are supported by our college and our university with entities in Arizona, but also other places in the US and actually worldwide. And our research is currently supported by the National Institutes of Health, the US Department of Veterans Affairs, and private industry. Now, this is just one example of infectious disease research in cows, and I would really like to emphasize that the College of Agriculture and Life Sciences is a leader in infectious disease research in this university. So in our college, we have ongoing studies in so many different kinds of infections, including foodborne and waterborne infections. And Dr. Ravi Shankar and Dr. Kerry Cooper, who are two important players in cows in this area, are actually on this webinar today. So a huge big shout out to all our infectious disease colleagues and faculty in this college. All of us together study infections caused by a really wide variety of organisms. So we study infections caused by bacteria, viruses, parasites, fungi, really anything you can think of. And we study infections that affect humans, animals, crops, and the environment. So last year, with the support of Dr. Shane Burgess and Dr. Parker Anton, we came up with this idea to integrate all of this fantastic infectious disease research in cows under a single umbrella. And the goal of that umbrella was to support the invention and development of drugs and vaccines that could prevent infections. And this umbrella is known as the Collaboratory for Anti-Infective and Therapeutic Strategies, or CATS. Dr. Vishwanathan and I lead this effort. The mission of CATS is to harness and expand both the scientific and entrepreneurial expertise to find solutions to both existing and emerging infectious diseases. So what CATS does is to support scientists in cows and at the U of A to design treatments and preventives, and really to bring these to market with the help of multiple different industry partners. Infectious diseases are here to stay. With or without COVID-19, we will have all of the infections that we had before this pandemic also continue after this pandemic. So we think it's really important to basically continue research into all different kinds of infections and design ways to both prevent and treat them. For our product partners, this is an untapped multi-billion-dollar effort that I think we really need to be playing in, and that is really the focus of the CATS Collaboratory. So this is my last slide, and I would like to leave you with this CALS-sponsored effort, the goal of which is to provide collaboration, seed funding, intellectual property protection, and really bring infectious disease products which are market and stakeholder focused into the limelight with the support and the really great input of both the College of Agriculture and Life Sciences and the University of Arizona. So I'm happy to stop there and take any questions.
Thank you, Gayatri. You know, something that occurred to me as you were speaking is that even beyond the impact on infectious disease, the work that you're doing and the work that our CALS researchers are doing has a tremendous economic impact as well. CALS research creates nearly 1,000 jobs, and everybody that we've seen in the video and in the pictures in your slides are among those. And so thank you for everything that you're doing, helping to keep us safe, healthy, and keeping our Tucson community on track. We do have some questions that have come in, and for those of you that are on the webinar, please feel free to keep putting those in the Q&A, and we will just take care of those one at a time here. The first is from Larry Callaghy. Will the product be available to the general public? That is the hand sanitizer from the Bend the Curve project.
Correct, yes. So thank you for that question, Larry. The product is currently available at cost to our mission partners. And because of the amazing and incredible demand that we have, we are focusing on supporting our healthcare facilities and our CALS mission partners at this time. But please do feel free to get in touch with us. And if that changes, we will let you know.
Excellent. We have another good question from Tom Jones, actually two questions. One, for the hand sanitizer, what's your production cost per liter or per unit that you're producing? And what's the anticipated lifetime of the project? And do you have a growth or exit strategy?
Great questions all, Tom. So right now our product is being made available at a cost of about $470 for 8 gallons. So which comes out to a little bit over $50 a gallon, which is extremely competitive in this market. What is the anticipated, the shelf life of this product is about 3 years. And for sustainability of this entire project, it's a great question. We were just talking about it this morning. We are an infectious disease research group, as I mentioned, and the research that we do has to continue. But at this point, we are planning on supporting our mission partners if they need sanitizer. So at least for the next few months, if not more, we will provide product to those who need it. Do we need an exit strategy at some point of time? Yes, we do. If Shane wants to comment on that or anybody else, I'll be happy to hear their input as well. We were just completely overwhelmed by the demand and the need for this product. And as you know, the cases of COVID-19 infection continue to rise precipitously in the state of Arizona. So the need for our hand sanitizer is concomitantly high as well.
Excellent. So we touched on it earlier in your presentation, but can you define for us what you mean by mission partner in terms of availability, and who are those people, and what makes up the organizations and people on that list?
Right, so as a land grant university, as you know, Alex, we have research, teaching, and extension as our 3 missions. Through our extension efforts, there are a number of entities that CALS interacts with and really has a lot of contact with. We have communities all across the state of Arizona. We have industries, and then we have entities like the Reed Park Zoo, for example, with whom CALS and the university have existing collaborations, and those are our mission partners. Ultimately, if this goes out into the Arizona community, our stakeholders, our population in Arizona is the most critical mission partner. This is being done for you. We are just trying to, at this point of time, work with those entities with whom CALS already has existing relationships and getting the product out as quickly as we can.
We have another question here from Beth Martin about your C. diff research. Have you tried the C. diff liquid that you created on humans yet? who have the disease?
Thank you, Beth. Not yet. To go into a human clinical trial, as you can imagine, takes a lot of effort. That is where we are heading. In order to go down the human testing route, we have to have a lot of interaction with the FDA and get permission to do so. And that's the direction in which this research product is headed. But ultimately, this C. diff product is to be a safe and oral preventive for anybody that is at risk of the disease, whether or not they have to go into a hospital. So thank you for that question.
Yes, thank you. All right, so I don't see any more open questions in the chat. Gayatri, do you have any closing thoughts before we go?
Just to thank everybody for this opportunity to share some of our research with you. And this Bend the Curve Sanitizer project would not be alive and well today without the incredible support of our Arizona community. We're so grateful and so humbled and honored to be able to work with all of you. Please keep the suggestions and the questions coming, and we will be happy to address them.
Excellent. Thank you, Gayatri. Thank you, Shane, for presenting today. We really appreciate your time. This has been very informative and a ton of fun. So with that, we can draw things to a close. I've dropped a link in the chat for everybody that's attending. If you want to learn more, you can follow the links, or if you want to contribute, you can follow that link too. Thank you, everybody, and have a great day.
Thank you.